How's it going, guys? In today's video, we're going to be going over 7.4, day 1, dividing polynomials using long division. So, if you guys need a quick reminder on long division, I'm sure you can go on YouTube and find many videos kind of give you a quick rundown of how to do long division. In this video, I want to focus really on just using long division with polynomials. So, when we're dividing two polynomials using long division, we need to remember a couple things. First, or really a few things. First is that we want the terms to be in standard form, okay? We want the divisor and the dividend to both be in standard form. Or in other words, we want the degrees to be going from largest to greatest. For example, x cubed minus 2x squared plus 7x plus 3. It's going from highest degree to lowest degree. That's what we want. And if there's ever a term that's missing, for example, we have x cubed plus 2x minus 5. We're missing that x squared term. We're going to put it in with a 0 coefficient. It's going to be kind of a placeholder. It helps make everything look nice. It keeps everything organized when we're doing long division. And since we're doing long division of polynomials, we have a lot of variables, a lot of numbers, and a lot of degrees all over the place. You want to be as organized as possible, and putting in placeholders with 0 coefficients will make your life much, much easier. Okay? And also, many times when you're dividing polynomials using long division, you're going to get a remainder. And if there is a remainder, we're going to write it as the quotient, or really our number right here, the x minus 3, plus the remainder divided by the divisor. Okay? And you're going to see what that's going to look like in the next two slides. And also, like everything else in math, there's always a way to double check your answers. And in this case, you can write the dividend is equal to the divisor multiplied by the quotient plus the remainder. So set it equal to each other, or rather plug in everything that you have into that equation, simplify as much as you can, and if that statement holds true, if the equation holds true, then your answer is correct. Okay? So let's go ahead and actually do a problem. Math is better shown when you're actually doing a problem. And here we have number 1. Okay, we have 4x cubed plus 2x squared plus 3x plus 5 divided by x squared plus 3x plus 1. So let's go ahead and put it into our dividing, I don't know what it's called, but let's just go ahead and just write it out. 4x cubed plus 2x squared plus 3x plus 5, all divided by x squared plus 3x plus 1. That little dividing hat is what I was talking about. So we put it into our equation over here, right? And now we're going to divide. And when we're dividing polynomials, what we're going to do is look at the first term of the divisor and the first term of the dividend. Okay? And we're going to see how many times the first term of the divisor goes into the first term of the dividend. So x squared goes into 4x cubed how many times? Or another way to think about it is x squared times what gives you 4x cubed? In this case, it'll be 4x. 4x times x cubed gives us 4x cubed. Sorry, 4x times x squared gives us 4x cubed. Okay? And that's what we want. We want to match the terms underneath the little dividing hat. So 4x times x squared is 4x cubed. Then we're going to multiply the 4x with a 3x and the 1 as well. 4x times 3x is a positive 12x squared, and 4x times 1 is positive 4x. And what I like to do personally is I like to just add zeros for every term that I'm missing. You don't have to, you can just bring it down, but I think this kind of just makes it a little easier to see and a little more organized, right? And like I said before, we have a lot of variables, a lot of degrees, a lot of numbers all over the place. If you can be more organized, it's probably going to benefit you. So now we're going to subtract the first polynomial with the second one we just made. 4x cubed minus 4x cubed is 0. 2x squared minus 12x squared is negative 10x squared. 3x minus 4x is negative x, and 5 minus 0 is just positive 5. Okay? And now we're going to do the same thing with the first term here, is x squared, with the first term over here, negative 10x squared. So we're going to see how many times does x squared go into negative 10x squared. or x squared times what gives you negative 10x, or sorry, negative 10x squared, and we know that'll be negative 10, right? Negative 10 times x squared is negative 10x squared, which is what we want. So we're going to do the same thing, take that negative 10, multiply it by the divisor, and put it underneath our other polynomial. So negative 10 times x squared is negative 10x squared. Negative 10 times positive 3x is negative 30x. And negative 10 times positive 1 is negative 10. And we're going to minus the first polynomial with the second one. And something else I wanted to kind of note is that what I like to do is I like to put a subtraction sign and then a parentheses around the second polynomial. I think it just makes it a little easier to see that I'm subtracting the first polynomial with everything in the second polynomial, and I don't get confused in my signs. So if you can, I think it will be very beneficial if you do it this way. Put the subtraction sign and put the parentheses around the second polynomial. So that little side on the side, we're going to finish subtracting this now. Negative 10x squared minus negative 10x squared. Same thing as negative 10x squared plus positive 10x squared. It's just going to be 0. Negative x minus negative 30x. Same thing as negative x plus positive 30x is a positive 29x. And 5 minus negative 10 is the same thing as 5 plus positive 10. Remember, change the sign, add a line, and that gives us 15. So now what we're going to do is we're going to see how many times does x squared go into 29x. And we can see there is no number, no whole number that we can multiply x squared with to give us 29x. It doesn't exist. And your whole number won't exist. So from here, we're going to say, well, we're done. That right here, the 29x plus 15 is our remainder. Whenever you get to the point where the first term of the divisor has a higher degree than your exponent, sorry, the first term of the polynomial you just got, we subtracted, that's when you stop. So x squared has a higher degree than 29x. We're done, we can stop. And then we can write our answer as our quotient of 4x minus 10 plus our remainder of 29x plus 15 divided by our divisor of x squared plus 3x plus 1. Okay, so it's very similar to regular long division with numbers. The only difference is we have exponents and polynomials rather than just straight numbers. Okay, so that's the first one. Let's go ahead and do a second example too. I think now that you know kind of what to expect, what we're doing, following along on the second example will be much easier. So for number 2, we have 3x to the 4th plus 5x cubed plus 2x plus 8 divided by x squared plus 2x minus 5. One thing to pay attention to right away is that our divisor right here doesn't have an x squared term, right? Or sorry, our dividend. Our dividend doesn't have an x squared term. So that means we need to put in a placeholder when we're putting it into our little dividing hats, whatever it's called. Okay? And that's so we can keep ourselves organized and we don't get lost trying to solve it. Okay? Like I said, it's a lot of variables, a lot of degrees, a lot of numbers. It's very easy to get lost. Stay as organized as you can. So we're going to put in a placeholder. So we get 3x to the 4th plus 5x cubed plus 0x squared. Remember, it has to be 0x squared, not just x squared. X squared says you have a coefficient of 1. 0x squared means it's just 0. I don't want to say nothing, but it's empty. That's what you want. You want a 0x squared. All right? Plus 2x plus 8, all divided by x squared plus 2x minus 5. All right, so like we did before, we're going to compare the first term with the first term. X squared goes into 3x to the 4th how many times? Or x squared times what gives you 3x to the 4th? In this case, it's 3x squared. 3x squared times x squared is 3x to the 4th. So we're going to take that 3x squared, multiply by everything in the divisor, and put it underneath our dividend. 3x squared times x squared is 3x to the 4th. 3x squared times 2x is a positive 6x cubed. And 3x squared times negative 5 is negative 15x squared. All right, and that's another reason why we put the placeholder here. We keep all the degrees on top of each other, or in a column, in a row next to each other, and we don't get lost. Okay? And like before, we're minusing the first polynomial with the second one. I'm actually going to put plus zeros here. I feel it just keeps it a little more organized, so that's what I'm going to do. And we're subtracting everything. I'm going to put my parentheses just to keep myself, or sorry, just to remind myself that I'm minusing everything inside the parentheses, not just the first term. So 3x to the fourth minus 3x to the fourth is 0. 5x cubed minus 6x cubed is negative x cubed. 0x squared minus negative 15x squared is a positive 15x squared. And 2x minus 0 is just positive 2x. And 8 minus 0 is just positive 8. Okay? So now I'm going to do the same thing again, but this time with the last polynomial I have over here, the negative x cubed plus 15x squared plus 2x plus 8. So I'm going to see how many times does x squared go into negative x cubed. Or x squared times what gives you negative x cubed? That's going to be negative x. Negative x times x squared is negative x cubed. That's what we want. Negative x times x squared is negative x cubed. Negative x times 2x is negative 2x squared. And negative x times negative 5 is a positive 5x. And then we'll just put a plus 0 for the 8, so I don't forget about it. Put my parentheses, my subtraction sign, and now let's subtract these two polynomials. Negative x cubed minus negative x cubed. Same thing as negative x cubed plus positive x cubed. That's going to be 0. 15x squared minus negative 15x squared minus negative 2x squared is the same thing as 15x squared plus positive 2x squared. That's a positive 17x squared. 2x minus 5x gives us a negative 3x. And 8 minus 0 is just positive 8. Okay? And now we're going to do the same thing again. We're going to see how many times does x squared right here go into 17x squared. Or x squared times what gives you 17x squared. And this is going to be a positive 17. 17 times x squared is a positive 17x. Oh, sorry, a positive 17x squared, which is what we want. 17 times positive 2x is a positive 34x. And then lastly, 17 times negative 5 is negative 85. So let's put our subtraction sign, our parentheses, and we're going to subtract everything. 17x squared minus 17x squared is 0. Negative 3x minus positive 34x is a negative 37x. And 8 minus negative 85 is a positive 93. Okay? And now we need to see how many times does x squared go into negative 37x. So we have this this positive x squared. How many times does it go into negative 37x? There really is no whole number, really any number that you can multiply x squared with to give you negative 37x. X squared has a higher degree than negative 37x, so we can't really put in a whole number or an integer or anything like that into this quotient to give us negative 37x. So what I'm trying to say is we just stop here, okay? Because there's nothing we can multiply x squared with to give us negative 37x. So we stop here, and this negative 37x squared, this negative 37x plus 93 is our remainder. So what we do is write our quotient, which is 3x squared minus x plus 17. And we're going to add negative 37x plus 93, all divided by our divisor of x squared plus 2x minus 5. And this right here is our quotient for number 2, our answer for number 2. Okay? For number 3 and number 4, I want you guys to actually try to do it on your own. if you need to, you can rewatch these last two problems. Rewatch what I did. We do post a completed key online, so you can double check your work and kind of see where you went wrong, and you can kind of check yourself, see what you did wrong, and fix those mistakes. If you need to, you can rewatch this video. Anyway, guys, I hope it helped. Have a nice day.